Hey guys, this is Coach Brian bringing you the 4.1b notes. These are all about logarithms, which we'll obviously get into a lot more detail in class about what they are. The most simple thing that you need to know about logarithms is that they are the inverse operation to exponents. So if you remember the words we've been using specifically for inverse means to reverse something or to undo it. So this undoes exponential functions. It's also useful for simplifying really incredibly tiny or incredibly large numbers for things in physics, mathematics, engineering, all those things. But it's able to, or you're able to multiply and divide and even sometimes simplify that into adding and subtracting using logarithms. So we'll talk a lot about their applications in the upcoming lessons. But we really just want to know that they have a lot of uses in math and physics, and they can simplify equations, and they do come up a lot in calculus for integration and some other things. So let's go ahead and get to it. Hopefully you remember a good bit of this from Algebra 2. Just like a lot of this class so far, it's like Algebra 2, but up a level. So how do we even write a logarithm? When we're writing a logarithm, we would write log, and it has a base, b, an input, x, and it equals y. And we use this term a lot back in Algebra 2, but we use the term drop, cross, cross. Drop, cross, cross. We use that a whole lot back in Algebra 2. And it's kind of kind of a key for unlocking these when you first start working with them. So if you can remember drop, cross, cross, it will take you a pretty good ways. So pretty much if you kind of point out what's what here, our base number becomes the base of our exponent. And then whatever our log equals ends up being the power that we raise the base to, and x is just our solution. So pretty much logarithms are a way to find what exponent a base was raised to get a solution. So let's do a couple of examples. Log base 2 of 8. Again, if you didn't know where to start with this, you could drop, cross, cross, and you would just ask yourself, 2 to the what power equals 8? Well, 2 cubed is 8. 2 to the third power equals 8. And this is why, especially from last class, knowing your exponent rules is so important. Log base 5 of 1 over 25 is negative 2. And if you're wondering, how is that? Well, 5 to the negative second power is 1 over 25. And if you know your exponent rules, that makes sense, because whenever you have a number to a negative exponent, you can invert it, and then 5 squared is 25. So it just comes down to really knowing those exponent rules and kind of knowing your common squares, cubes, that kind of stuff. So what does it mean when there's no base? We have this example where you just see the word log a lot, and it's called the common log. And the common log has a base of 10. It's just kind of understood that when you see the word log by itself, has a base of 10. And so you'd be asking yourself, okay, 10 to the what power is 100? And your answer would be 2. 10 squared equals 100. Again, if you weren't sure about that, if you just had common log, 10 is understood to be right there, so you could drop, cross, and you'd say 10 to the what power equals 100? Well, 10 squared equals 100. We also have ln, which is the natural log. And this whole concept is a little mind-blowing in itself, but ln is the same thing as log with a base of e. So if we put that to the x, log e to the x. Anytime you see this, this is what it means. Log with a base e and your input of x. What is e? E is a number that represents a perfect growth rate. We'll talk about growth and decay in this unit, and E is the perfect growth rate, and it is approximately 2.718. In concept, it's similar to pi, where it just kind of keeps going, but they both have their own like unique and special uses and reasons for existing. So if you had a ln of e to the fifth, ln, okay, don't want to confuse you here, but ln is log base e. So you could write it out like this. You're like, e to the fifth, what? If you were to drop cross that, the answer would be 5. Because e to the fifth equals e to the fifth. Express the following in exponential form. So you can see all of these are logarithms. And we're trying to rearrange them. And we're going to use drop cross. And it's going to make pretty quick work. So to start with, drop your base, cross over, and you would ask yourself, is that true? 3 times 3 is 9, times 3 is 27, times 3 is 81. So yeah, checks out. Now, remember on this next one that ln is an understood e. So you would drop your e, cross your x, and cross your 5. E to the x power equals 5. Now on this one, the final one, drop our 2, cross our -3, cross our 1/8. And again, if you know your exponent rules, you know that this is right, because if you had 2 to the -3rd, you could invert it, and then 2 to the 3rd is 8. The following need to be expressed in logarithmic form. So now we're just kind of reversing the process here. You can still drop cross though. So this number, the base, is going to go down here, if you remember. And then this number is going to come back over, and this number is going to go back over. So in this specific situation, our log base is an e. So let me erase that and make that an e. Okay, log e. Well, we said that that is like one of the special ones. Log e is what we call our natural log. So we could just write ln 32 equals x. over here, we would drop our 1/9. Excuse me, sorry. We would bring over our, drop our 3. I didn't realize they switched sides on this one. If you see, this is the exponential side, this is the exponential side. So we always want to bring down the base of the exponent to be the base of the log down there. Then we would cross and cross, which means this one's all just messy. So let me just do this real quick. Let me just write this over here. That way this one's a whole lot cleaner. Log base 3 of 1/9 equals -2. And again, you can always double check your work. Say, does 3 to the -2 equal 1/9? Sorry, 1/9. Just ask, is that true? Well, 3 to the -2 is 1/3 squared, and that is 1/9. So you can always double check your work. Lastly, find the exponential side, drop the base, cross and cross. Log base 81 of 3 equals 1/4. I heard, or I was reading back over some old notes, and this is just kind of an aside, but it said that exponential functions are repeated multiplication. I'm gonna run out of room. And if you think about it, like 2 to the 5th is 2 times 2 times 2 times 2 times 2. And my answer for that would be 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. But what if I was going to make that logarithmic? Log base 2 of 32. Pretty much what you're asking yourself is, let me rewind real quick. A logarithm, say logarithmic, is repeated division. So up here you would say, how many times can I take 32 and divide it by 2? And that'd give me 16. Divide by 2. That'd give me 8. Divide by 2. That'd give me 4. Divide by 2. That'd give me 2. Divide by 2. That'd give me 1. And I was able to divide 1, 2, 3, 4, 5 times. Just like up here, I multiplied it 1, 2, 3, 4, 5 times. So I just felt like adding that in just in case you were having a little trouble conceptualizing exponential and logarithmic. All right, for these last two, it says evaluate, solve using logarithms. So pretty much we're setting these equal to an unknown. Setting these equal to an unknown. Setting these equal to an unknown. And we're trying to see if we can figure out what x is. So to do this, first we have the common log. And if you remember, that's technically a log base 10. And what we're asking is 10 to the what power equals 1 over 100. Well, if you know that 100 is 10 squared, you could be like, okay, I need this to be a 2, but I also need it to go to the base of a fraction. I need it to be flipped to the denominator. So that must mean that it's -2. And that's our solution. X equals -2. Always double check your work if you're not confident. 10 to the -2 equals 1 over 100. ln of 1, the natural log of 1. This is a special case where it's just kind of like a thing you memorize. It's a characteristic of e. So whenever you have the natural log, okay, you would bring down that e, and then you'd cross, and you'd cross. Now, this is just it's really just an exponent rule. Any number to a power that ends up equaling 1, it had to have been raised to the power of 0. And so in this case, natural log of 1 is 0. And just in case you didn't know, that's true for any number. 16 to the 0 power is 1. 25,000 to the 0 power is 1. It's just a exponent rule. Next, jump it down to C. We've got a base of 4. Bring it over the x. And then it equals the cube root of 4. So again, like another little special case of exponents here. I'm going to write the rule out for you. If you have a to a power, let me actually rewind it just a little bit more. If you have a to a fractional power, you can take that in right there, and it'll be your root. Notice where the 1 stays, the top number, whatever it is, stays right there. But this number leaves the bottom of the fraction and comes out here to be your root. Now, this one was 1 over an unknown. Let's say you have a with a fraction, m over n. Same rule, you could take the n and find the root of a to the m power, or another way you could write it is the n root of a to the m power. So I think that was on your exponent rules, but just in case it wasn't, write that down. Now let's look at this example. 4 is technically to the first power. And then this 3, we're finding the third root. We could bring it over here and put it in the base of a fractional exponent. So we could say that 4 to the 1/3 power is what we're looking for. And in that case, the unknown is the exponent. So we would say x equals 1/3. Now our very last one, I don't know if I have room to do it. So I'm going to create some room. I'm going to drop my base of 16, cross my x, and cross my 1 over 32. All right, this one's a little complex. Pretty much what we're saying is 16 to an unknown power equals 1 over 32. Now we'll get more into this, but there's a process where you can actually like change the base. And so you could ask yourself, 16 and 32. Through exponents, as is, I don't know if I can get there, but are they any exponential form with a common base? And so what I mean by that is, see how I can take 16 and make it 2 to the 4th? And then on this side, I can take 32 and make it 2 to the 5th. Okay, following with me? Following with me? 2 to the 5th is 32. Now, one last change, just knowing my exponent rules, I can take this whole thing and switch it to 2 to the negative 5th. And if you're wondering, like, why would you want to do that? It's because I'm trying to figure out what goes here. And I'm using my exponent rules to kind of unwind this thing. And so, again, knowing my exponent rules, I'm just going to make this open box a little clearer. But knowing my exponent rules, I know that a power to a power multiplies. So 2 times 4, whatever this unknown is, let's just say it's an x, is going to equal 2 to the negative 5th. Still following with me? So when two exponents have a common base, you can cross it out, set them equal to each other, and then to solve for x, you divide by 4. And so x, my unknown this whole time, equals negative 5 over 4. Negative 5 over 4. And you could, just to prove it here, you could test this out. Let's say we have 16. Help if I switch to the pen. 16 to the negative 5/4 power. Well, we just said, based off that rule we saw, that I could take this and move it out. And I could find the 4th root of 16 to the negative 5th power. Stay with me. Stay with me. The 4th root of 16 is 2. 2 to the negative 5th is the same as 1 over 2 to the 5th, which is same as 1 over 32, which matches up there. So you can prove it if you're doubting your answer and need to check it or double check it or whatever. You should always be able to reverse and check your work. All right. I feel like I'm moving a little slow for these notes, but that's okay. Change of base formula. Change of base is a property of logarithms to give logarithms a common base, and it kind of opens up the operations you can do. So let's say I have a log base b of x. I could take my base, okay, bring this log over here, give it a common base, let's say 10, and then I can take this one up here, give it the same base, and now I've got, even though I'm dealing with a fraction now, these are a little more manageable because it kind of opens up some of the operations I can do. So log base of x over common log of x and common log of b. So for this one, I'll let you practice it a little bit. Hopefully you're in class and can grab a calculator If not, try it when you get back to class. It says use a calculator and the change of base formula to evaluate log base 8 of 9. And so what we would do is we're trying to figure out what does this equal. And so if we were crossing it, we'd have 8 to the, I don't know, power equals 9. That's a hard, that's not a common square, cube, whatever, power. So that's why we would like to use change of base. Now, if you are, putting this in your calculator, and we were going to use our change of base, we could, again, take the base, move it to the denominator, leave this one up top. Can never make nice arrows. And then if you were to, this is technically, I know this is, you got to get this concept in your head. This is an exact answer. That's an exact answer because these might go on decimal point wise. They might be huge numbers. They might be tiny numbers. And we don't always write things, to the 100th decimal spot or something like that. It's not reasonable. So this is actually an exact answer. Now it says, let's round to the nearest thousandth for our calculator solution. And so you should get 1.057. And you're like, man, that seems pretty exact. But really, that's an approximation because we cut off who knows how many more decimal places. Now, we have just a couple left. It says you try with no calculator. So if you want to pause here, if you're watching and try them yourself, great. If not, drop, cross. 4 to the what power equals 16? Well, 4 squared equals 16. 4 times 4 equals 16. So the actual answer here is 2. X equals 2. Log base 2 of 13. I can already tell this one's going to be an unfriendly one because when you drop and you cross 2 to no power, or at least 2 to no common power, is 13. So what we could do here, we could use a change of base, and that would be our exact answer. And then you could put that in your calculator, which I don't have one on me right now, and see what you get out. Round it to 2 or 3 decimal places. Down here I've got LNE. Well, the natural log is log E. So pretty much I'm canceling these out. These cancel essentially. And my answer is 3. My answer ends up being 3. Because if I were to drop, cross, and cross, I'm saying e to the what equals e to the third. Well, e to the third equals e to the third. So my unknown here is 3. And then for my last one, I'm going to drop my 3. Cross my unknown over to my exponent, and that equals 1/9. And again, just to kind of show you these exponent rules, remember this is 1 to the 3 over positive 2, which can then be flipped to 3 to the negative 2. And so if you're like 3 to the x equals 3 to the negative 2, when they have a common base, x equals negative 2. So my unknown up here is negative 2. All right, that does it for our 4.1b notes. I hope this helps you a lot. And if you have any questions, ask me if I'm your teacher, or ask your other teacher if I'm not your teacher. See you in the next video.